All right, welcome back. We are jumping into section 4.6. I'm intentionally going out of order, so we're going to do 4.6 first and then go back to 4.5. I prefer it in that order when you're looking at the content. I am really impressed with how you guys have been doing so far with proofs, so good job and keep up the good work. What we are doing today is something called HL. Okay? Now, the start thinking part says the current methods we have to prove triangles are congruent. What have we done so far? S, 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 A, S, A, S, A, and A, A, S. Now, I want to remind you why those shortcuts work. These methods work because there is only one possible triangle that can be created if you know all the side lengths. There's only one possible triangle that can be created if you knew two side lengths and the angle between the sides, and so on. Let me show you an example of where that wouldn't work. So this works with all of the triangles. If you were looking at a four-sided figure, such as a quadrilateral, which is a four-sided figure, if I told you to make a figure that had all sides that were 4 inches, you could go over and make a square that was 4 inches, or you could have made a rhombus that was not a square that had all sides that were 4 inches long. Now, what I mean by this is there's more than one possible quadrilateral that you can make if you know all the side lengths. Therefore, S, 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 S would not be enough if you are looking at quadrilaterals to prove that they are going to be congruent. Now, lucky for us, we're only working with triangles. So all of these are the shortcuts for proving that two triangles are congruent. Now, with that said, we've already talked about why AAA does not work. Just looking at angles would not be able to be used to be able to prove two triangles are congruent. For example, you could have a triangle that was 1 by 1 by 1 and all of the angles are 60, 60, 60. And then you could have another one that was 60, 60, 60 and could have like 4, 4, and 4. So just knowing the angles is not enough to be able to prove that two triangles are congruent. Now we have one that we have not been quite sure about, and that is SSA. So it's kind of been our questionable one. Maybe it works, maybe it doesn't, and we're going to look at it right now. So if we took a look at this figure right here and we had a 45-degree angle and then we had a 10-inch side and a 9-inch side, is there more than one possible triangle that can be created? So let's say we're locking in this at 45 degrees. Okay. Now, think about this. If we locked this side in at 10 and we did not move it at all, here's one possible triangle that we could have. Right here, the one that they drew. Now another one, we could go over and start moving that in this direction. If I move it a little bit, it's too long. Okay. You would have to change the angle, which we're not allowed to. But as it keeps going over and moving, it will lock back in place at another time. And there would be a second triangle that could also have 9 inches, 10 inches, and 45. So you'd be able to have, it's basically this side here swinging. It would swing out and it would be too long and then it would snap back in place. So since there's two possible triangles that could be created, knowing a side, then an angle, we could not use SSA. Now, there is one case where it is impossible to have this aspect of the side swinging and locking back in, and that would be if the angle was right. Now, if this was 4 inches and this was 5 inches, this is the only place where that side could lock in. It's not like if I started moving this out, it would just be too short. It wouldn't be able to reach all the way to that side. If I moved it the other direction, it would be too long and it would be changing the angle. So this is a case where it is impossible for you to be able to have two different triangles because the side only locks in once. I understand that this is a little bit of a confusing concept. But basically, what I'm getting at is that SSA does work, but only when this is a right angle. It won't work when you have different angle measures. So rather than saying SSA does work in this case, they name it something different. They name it HL. HL stands for hypotenuse and leg. So basically what it means, if the hypotenuse, go ahead and write it, if the hypotenuse and leg of one right triangle are congruent to the hypotenuse and leg of another right triangle, then the two triangles are congruent. Once again, we don't call it SSA because there's many times when SSA does not work. We call it HL. Let me give you an example. If you had that triangle and this triangle, they're both right, and you name that they're right in a proof. Then you see a leg is congruent to a leg, and the longest side, the hypotenuse, is congruent to the hypotenuse. Could have been the other legs also. Then the two triangles are going to be congruent. That is the last way we are going to show that triangles are congruent. We had SSS, SAS, ASA, AAS, and now you have HL. There aren't any other ways that we are going to prove triangles are congruent. So let's go through here. The three things that you need to be able to prove inside of your proof to show that the two triangles are congruent would be: 1, a leg is congruent to a leg. Somewhere in your proof, you're going to need to show one of the shorter sides is congruent to one of the shorter sides. The other thing in your proof, you need to show the hypotenuse is congruent to the hypotenuse. And the last thing that you need to be able to do is show that the triangle is right. It's not enough just to say that the angle is right. You say the angle is right and then the triangle is right. It's just kind of a weird thing with HL. So once you have these three boxes checked off in a proof, then you can finish and say that the two triangles are congruent by HL, hypotenuse leg. Let's go ahead and go to another. So if we were looking at this right here, and we were trying to figure out if these two triangles had to be congruent by HL. See if we can check off a box for hypotenuse, check off a box for leg, and check off a box for right triangle. Right angles, if it's a right angle, then it's a right triangle. Check off that box. Now we have a leg congruent to a leg. Check off that box. And across from your right angle is going to be your hypotenuse. So that is the longest side. By the reflexive property, you can show the hypotenuse is congruent to the hypotenuse. You've checked off your last box. So these would be yes by HL. Now the next one, leg, hypotenuse, right triangle. Well, the reflexive property does the leg congruent to the leg. These right angles right here would be the right triangle. Is there any way to show that this is congruent to that? I do not see any way that we can show that those are congruent. So I am not able to do this. Therefore, no HL. Cannot do it. If you look at this, we want to know what else you would need to know to be able to show that the triangles are congruent by HL. If we know AC is congruent to DF, and angle A is right, and angle A is congruent to D, then what else would we need? We've checked off our box for legs. We've checked off our box for right triangles. What else would we need? Well, we need to check off our box for hypotenuse. So we would have to show that BC was congruent to EF. That would allow us to finish the proof by HL. Now this one says we know that J and D are both right, so therefore we know the triangles are right. What else would we need to know to be able to use HL on this one? Well, on this one, we would need to know that this side is congruent to that side, and that would be your H part. And then your L part would be that you need to know that two of the legs are congruent. So let's skip this one. Skip this one. Let's go ahead and look at this. Is there enough to be able to show these two triangles are congruent by HL? Do you have a hypotenuse, a leg, and right triangles? Yes, you do. They have given you that the hypotenuses are congruent. Check. The reflexive property would be a leg is congruent to a leg, and the right angles make the right triangles. Check. Okay. Now, let's go ahead and show how this all comes together into a proof. Now, on this one right here, this is going to be a little bit annoying. Why is it annoying? Because they say it's perpendicular. Perpendicular will lead to the angles are right, and then the angles are right will lead to the triangles are right. But those are all three different steps you're going to need to have in your proof. You cannot just say that it's perpendicular and assume that they know that you have right triangles. You're going to have to go through the whole entire process. Let me go ahead and show you how this works. Statement reason. We're going to start with RT is perpendicular to SU, given. Now, if those are perpendicular, by definition of perpendicular, you will have right angles. So we can say angle RTS and angle RTU are right. And that would just be definition of right. Oh, sorry, not definition of right. It would be definition of perpendicular. Definition of perpendicular. They're perpendicular, therefore they're right. Now, if they're right, now what we have to do is state that the triangles are right. I know that this is a little bit irritating that you have to do this each time, but you do. Triangle RUT and triangle RST are right. And that would be def of right triangles. Okay, next. So this part right here is us checking off our box for right triangles. Check. Now, if we had RU is congruent to RS, RU is congruent to RS, that would be given. And that checks off our box for the hypotenuse part. Check. And now we just need to have our last piece, which is a leg congruent to a leg. That would be RT is congruent to RT. By which property? How do I know RT, the leg is congruent to the leg? Reflexive property. Reflexive property, that would be my leg congruent to the leg. So now I have every part that I need, and I could say triangle RUT is congruent to triangle RST by HL. And there we go. So if there are any proofs that people have issues with, it's usually these ones because of this part right here. They have trouble figuring out how, number one, how am I going to use a right angle? Am I going to say they're right angles, therefore they're congruent? Or am I going to say they're right angles, therefore they're right triangles? The way that you use right angles is if you are going to HL, then you say they're right angles, therefore they are right triangles. And for any other ones, if you're using right angles with SAS, ASA, AAS, if you're doing any of those, these you would say the triangle or the angles are right, therefore they are congruent. Whereas with HL, we don't care that they're congruent. We want to use the right angle aspect to say that the triangles are right. All right, let's keep on cranking. Really, we have learned everything that we need to know from this section. The rest of this is just practice. Okay, so if we were looking at this, we need to figure out how we're going to finish our proof. Are we going to finish it with SAS or are we going to finish it with HL? What are we going to do? Because right here, for example, we have vertical angles. We can either use those as vertical angles if we're going to finish with SAS or one of those ones, or we can use those right angles for right triangles if we're going to finish with HL. So let's figure this out. We know that AD bisects EB. That means AD is like a knife. It is cutting AB in half. So we know those would be congruent. We also know that these angles are right, therefore the triangle is right, and then we know that side is congruent to that side. How are we going to prove the two triangles are congruent? Are we going to prove via HL or something else? Well, we have right triangles. We have legs congruent to legs and hypotenuses congruent to hypotenuses. So we know, and remember, a hypotenuse is just the longest side of a triangle, hypotenuse. So we're going to be using HL. First step, let's go ahead and say that the angles are right. ECD and angle ACB are right, given. Now, since we're going to HL, we're not going to say they are right, therefore they're congruent. We're now going to state that the triangle's right. Triangle ACB and triangle DCE are right. Def of right triangles. Now, lucky they didn't give us perpendicular, because then that would have just added perpendicular, then they're right, and then triangles are right. We now have the right triangles. Check that box if you want. You guys don't actually have to do this. This is just me noting what I'm doing as I go. The next one was AD bisects EB, given. Now, AD is like the knife cutting EB in half. It does not say they bisect one another. It just says that AD is cutting EB in half. So the only ones that are congruent now are EB is congruent, sorry, EC is congruent to CB, by definition of bisect. Some books do this weird thing where they go to saying that C is the midpoint, and then if C is the midpoint, then they're congruent, but we can jump straight to saying that they are congruent. Our last step is going to be what they showed here, AB being congruent to ED, which is given. I've now checked off the box for right triangles. I've checked off a box for legs congruent to legs. I've checked off a box for hypotenuse congruent to hypotenuse. I am done. Triangle ACB is congruent to triangle DCE. And that's by HL. Remember, HL is just SSA, but the special case where it actually works, because normally SSA cannot be used because there's two possible triangles. I will try to draw that one more time as an example. So if I knew this angle was 40 degrees, that's 10 and that's 8. Here's one way it can work, or you could have grabbed this and moved it, and then it would have locked into place up here. So you would have had two possible triangles, which means SSA cannot work. I am going to skip this one because I think we've got enough examples here, and then we will go down to the bottom one, and that's what we're going to finish with. So right here, if this was a fill in the blank, if we were going over and trying to figure out which one of these givens made sense to be able to say the angles are right, is it knowing that the sides are congruent, or is it knowing that you have perpendicular things that will lead to knowing that you have right angles? You need to know that those are perpendicular. Okay, therefore we know that the angles are right. Angle LMO and angle OMN are right. Oh, oops. Okay, this is the problem. Now, it was actually good that we were running through this. I was going to go over and do this by HL, You know what I didn't do? I didn't think through the proof to figure out how we were going to do this yet. We know that these are congruent. We know we have right angles, and we know that that is true by the reflexive property. So, are we going to finish with HL or something else? Well, we don't have the hypotenuses, so we're not going to do that. Instead, what we're going to do is we're going to use the right angles as congruent angles, and then we'll have an S, an A, and an S. So we are actually going to do this by SAS rather than by HL. We do have the legs, but we don't have the hypotenuses, so we can't do HL. So where we get at, we state that these are right, and we state that we state that these are perpendicular, therefore the angles are right. But now, instead of saying the angles are right, therefore the triangle is right, since we're doing not HL, we would move to saying the angles are congruent. Okay, that's the difference of how we use right angles with HL versus everything else. So right here is our A. Now what is the other given? ML is congruent to MN. That would be it looks like our leg part, but it's not a leg, it is an S congruent to an S. And then our last part is OM is congruent to OM by reflexive prop. That would be your other S. So it looks like SSA, but it's not. When you actually look at the figure, the angle is between the sides, so this would be SAS. I want to make sure I'm super clear. How do we use right angles? If we are going to HL, we would say the angles are right, so the triangles are right. If we are going to any other one, we say the angles are right, therefore they are congruent. Because for like SAS and all those, we want congruent angles. We don't care that they're right. The only reason we care that they're right is because that means that they are congruent. Just a little wrap up. We now know SSS is enough for showing two triangles are congruent. SAS is also enough. ASA is enough. AAS is enough. Now, SSA is not, but there is a special case where it does work, so we call it HL when it does work. These are going to be the 5 ways that you are going to prove triangles are congruent. With all of these ones, right angles are cool because we know that they're congruent, whereas with HL, right angles are cool because that makes us have triangles that are right. That's the different way that we use right triangles. I mean, right angles. All right, hopefully that made sense. Let me know if you have any questions. We're going to be going over this when we meet in synchronized class. Bye-bye now. You can also come to my office hours or meet with Miss Ruiz.